Hey everybody, Chad here from the Electric Academy. The two topics I find I get asked the most about, one is motor control, two is three-phase power. I've done a ton of three-phase power videos. I have done a ton of motor control videos. You can see the three-phase power videos up top there. You just click on that eye. Same thing, wait a second here and you can see the playlist for the motor control videos, clicking on that eye there as well. But today what I thought I would do is, because I had a student ask me yesterday about three-phase motor connections, and he asked about the 9-lead connection because he had heard from work that they've got these 9-lead connections and he wondered how they worked. So we're gonna split this up into like a two-part mini series. I'm gonna do one on a Y connection and one on a delta connection. I'm going to assume that you have a basic understanding of three-phase power. So if you don't, make sure you go back to the playlist and check it out just to get a rudimentary understanding. Again, you can check those out up top there and click on that link and then come on back to this video and we'll go over the 9-lead motor. Now the best way I can describe the 9-lead motor is to get off the screen and to get onto the white screen. So I'll see you on the inside there. Okay, here we are. We've got two different configurations. We've got a delta configuration and we've got a Y configuration. In this video, we're just going to be going over the Y configuration. We're going to go over the delta configuration in a later video. So again, today's the Y configuration. It's a 9-lead motor because we have actually 2 windings per phase. See here, we got 1 winding, 2 windings, 3 windings, 4 windings, 5 windings, 6 windings in total, which means we have 1 lead, 2 leads, 3 leads, 4 leads, 5 leads, 6 leads, 7 leads, 8 leads, 9 leads. We have ourselves a Y configuration connection with 9 leads. It's a 9-lead motor connection. Very, very common. So let's take a look at what we're dealing with here. With the 9-lead motor, it allows us to connect to 2 different voltages depending on the situation that we need. Now in this case, a very common motor that you might see out there would be, say, a 230 volt, 460 volt motor. Now, when you look at the nameplate, the motor, if it's a 9-lead motor, it will state on it that it'll have a 230, 460 on it, which means that you can connect this motor to 230 volts, the lower voltage, or 460 volts, the higher voltage. Now what we're going to go over today is how to connect to both these voltages, not at the same time obviously, but how we can get these lined up, because you want to make sure that if you've got it connected as a 230 volt, you're not going to connect it to 460. So that would be very bad. You would let all the smoke out of the wire if you did that. Now what we're going to do here is, the first step when we're working off these is we number our leads. Now I'm going to show you the convention that I was taught and that I teach. So what we do is we start at the top, and that would be number 1. Number 1's right there. And then we work counterclockwise. So we end up with 2 there, 3 there. And then we start doing the swirly method or the toilet bowl method or whatever, but you're kind of working a spiral into it. So we end up with this being 4, this lead being 5, this lead being 6, this lead being 7, this lead being 8, this lead being 9. So we've worked our way around the leads and we've got it down. Now we have a 10, 11, and 12. That would be 10, 11, and 12, but you notice that they're all internally connected to that star point. So we don't really count them. I don't really draw them out or talk about them that much. But just know that they do exist and that they are connected, and that's what connects this into a Y configuration. Now what we need to do is we need to figure, are we connecting to a lower voltage or a higher voltage? And if we're going to connect to a higher voltage or lower voltage, that means we're going to be connecting these leads in parallel or in series. Now we're going to start with the lower voltage first, because I find it's the trickier the voltages to deal with here. So I'm just going to go ahead and erase this out of the way. So what we're going to do here is, when we're dealing with voltages in parallel, the one thing we have to remember is parallel voltages remain the same. So what we have to do is we have to say, okay, if we're connecting these in parallel, we're going to have a situation where we have our windings. So these windings here will be in parallel with those windings. These windings will be in parallel with those windings. These windings will be in parallel with those windings. What I like to do and what I teach my students to do is I have them draw out, because they're very familiar with how these loads work. If you have this, so we have that set of windings, and then we're going to go off here and we're going to take these, and we have that set of windings, and then another 120 degrees we have this set of windings. I'm going to start at the top and I'm going to say, okay, I've got 1 and 4 here. So let's just change my color here. 1 and 4, that's that winding. And I'm going to connect 1 to 7. And then 7 is going to go to that lead that's at the bottom there. We're not going to count that. I don't want to confuse us, so I don't have it written out, so I'm not going to draw it. I know some who teach this would draw in the 10 and 11, 12 leads. I'm not going to do that. So we move over to 2. So I've got, say, 2 here, and I'm going to go counterclockwise again. So this would be, I've got 2 and 5. Well, 2 I'm going to connect to 8, and then it connects to the, again, the phantom lead, if you want to call it. And then I've got 3, so I'm going to call it 3 and 6. And I'm going to connect that to 9 and the other lead there. So this shows us now that we are going to parallel 1 and 7. We're going to parallel 2 and 8, and we're going to parallel 3 and 6. And you notice here that we're also going to connect 5, 4, and 9 together. So if we drew this out, and bear with me because this drawing might not be the best, but I will take basically 1 and 7, and I'm going to go 2 and 8, and I'm going to go 3 and 9 across there. And then what I'm going to do is I'm going to connect 4, 5, and 6 together. So 4, 5, and 6 together. And then we've got that connected properly for our lower voltage, because we have these in parallel. Remember, voltages in parallel stay the same. So if I look up here at this here, line 1, line 2, line 3, line 1, line 2, line 3 would be our 3-phase power coming in. So I would have, say, line 1, that would be L1, line 2, L2, and line 3, L3. So we see that we're connecting our L1, and it gets connected to 1 and 7. So 1 and 7. L2 connects to 2 and 8. 2 and 8. And L3 connects to 3 and 9. And then we see that we're connecting and joining 4, 5, and 6 together. And we're done. And there you go. That's the hardest part of the Y connection, is making sure you understand that whole parallel connection. Now our next one is super easy. We're going to go over, and it's going to be the higher voltage. Now higher voltages, when they are in series, you add them. So if we have 2 voltages, say that each one of these windings is rated for 230 volts. Well, 230 plus 230 is going to give us 460. So we do the exact same thing as we did before. We're going to number it, and we should be getting ourselves to be quite expert at this by now. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then our phantom leads on the inside that are all connected. So when we try to connect these out, it's the same idea as before. I don't even have to redraw the circuit. We just know that if we've got 230 volts here and we want to get 460 across it, each winding is rated at 230. We're just going to connect them in parallel, or sorry, we're going to connect them in series. So that becomes very easy. Watch this. We're just going to go boop and boop and boop, right? So we got those connected. And again, we can connect our line 1, line 2, line 3. There's our L1. We'll go like this. This is L2. And we can connect this, and this is L3. So our line 1 connects to 1, line 2 connects to 2, line 3 connects to 3. And then for our joining points, we are going to connect 4 to 7, 4 and 7. We're going to connect 5 and 8. And we're going to connect 6 and 9. 6 and 9. And then we're done. And we've got it all connected up for a higher voltage. So again, they're not too hard to deal with when we're dealing with the whole 9-lead connection. Quite easy, actually, if you understand how parallel and series circuits work. If you don't have an understanding of how parallel and series circuits work, go ahead and you should see a little I in the bar up top there. That's going to be a link to a parallel series connection for you. That's all I have for this week. Next week, we will be going over the delta connection, which is a little trickier, but not too much more so, and we'll go from there. As always, if you're getting any value from these videos, make sure that you are clicking on subscribe, ringing that bell, and please leave a link down in the comments below. I would love to hear, are you working on 9-lead motors? And if you are working on 9-lead motors, are you dealing with Y configurations or Delta configurations more often out in the field? Have a great week, everybody. Chad here from the Electric Academy telling you to stay classy.